We're going to look at graphing a rational function with more than one vertical asymptote. So what you see here in this picture is the graph of 1 over x. And if you think about it, that has a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0, right? Because it's bigger on bottom. So I just kind of want to pay attention here and look at the behavior of the graph as x approaches that vertical asymptote from each side. So we're thinking about this vertical asymptote and what happens as the graph gets closer and closer to it, right? So if we look at it, we can kind of see what's happening, right? As x approaches 0 from the left, so we're coming from this side and going down, the function is approaching negative infinity, right? The values are getting more and more negative. Now, notation-wise, when we want to say that it's approaching from the left, we put a little superscript negative sign there. What about as we approach 0 from the right? If from the left is a negative, then from the right must be a positive. So as we approach 0 from the right, we're following this. Notice my graph is increasing, right? So it's approaching infinity. When there are two vertical asymptotes, we've got to look at the behavior of the graph on each side of each vertical asymptote to determine what's happening in the center. So notice this graph here does not cross the horizontal asymptote, but this graph does. I know that's not intuitive because it's an asymptote and we shouldn't be crossing those, but it does happen. So to graph these, the first thing we're going to do is find our vertical asymptotes, which they are x equals whatever happens when we set the denominator equal to 0. Then we're going to determine the behavior of the graph on each side of each of those vertical asymptotes, which we'll go through. Then we're going to find the horizontal asymptotes using our mnemonic, Bobo Botan eats DC. If the power of x is bigger on the bottom, it's y equals 0. If the power of x is bigger on top, there is not a horizontal asymptote. And if the exponents are the same, we divide the coefficients. Next, we'll find x-intercepts, which are zeros of the numerator. Then we'll find the y-intercept, which is what happens when we let x equals 0 and solve for y. And then we'll plug in x values as needed. Notice our instructions say start by drawing vertical and horizontal asymptotes, plot the intercepts if there are any, and this says plot at least one point on each side of each vertical asymptote. So we don't need as many points as we needed in the others. All right, so the first thing I'm going to do with this is I'm going to factor that denominator. So I'm going to rewrite this guy. This denominator here, xx plus plus. Two things that multiply to give me 12 and add to give me 8 are 6 and 2. And I've got a negative 12 up top. So the first thing I know is that I have vertical asymptotes at x equals negative 6 and x equals negative 2. So I'll just go ahead and pop those on here, negative 6 and negative 2. So the next thing I want to think about is what's happening on each side of those asymptotes. So if x is less than negative 6, so let's think about as x approaches negative 6 from the left. So we're approaching from over here. And we're using this function. So if we are less than negative 6, my 12 is going to stay negative, right? What about the denominator? If I'm less than negative 6, like maybe a negative 8, this factor will be negative, and this factor will be negative. And this becomes negative over positive, which is negative. So as x approaches negative 6 from the left, my function approaches negative infinity. So that tells me that somehow over here, this graph is going down. Looking at what happens as x approaches negative 6 from the right, so now we are greater than negative 6, but still negative, right? You could think about it as like negative 5.5. So my numerator is still negative. But now, if I'm at negative 5.5, this factor is positive, but this factor is still negative. So my function is approaching infinity. So positive. So this guy is going up. We're going to do the same thing at negative 2. As x approaches negative 2 from the left, so we're negative values, we're less than negative 2. We still have a negative in the numerator. This factor will still be positive, and this factor will still be negative, right? Think about it as if we were plugging in a negative 3, right? We would get a negative value for that factor. So that means the function is still approaching positive infinity. So over here, we're going to be up. And then checking negative 2 from the right. So we're coming in over here. So we're greater than negative 2. We still have that 12 is still negative. I'm going to have this factor positive and this factor positive. Because if I'm coming from the right of negative 2, maybe I'm at negative 1, this factor would be positive. So now I'm negative over positive, and my function is approaching negative infinity. So I can kind of see what's happening here. Next, we would want to talk about the horizontal asymptote, and this is bigger on bottom. Right, so y equals 0. So notice I have a horizontal asymptote. These two guys are up. These two guys are down. So what I'm expecting is graph here, graph over here, graph over here, right? Because we don't cross the x-axis. And we know we don't cross the x-axis because both of these are up, right? There's no reason to. The next thing we're going to look at is x-intercepts, which are zeros of the numerator. There is no way for negative 12 to equal 0, right? And we're not surprised that there's no x-intercepts because that is our asymptote, and our behavior here showed us that we shouldn't cross it. Next, we'll look at the y-intercept. For the y-intercept, we are looking at f of 0, right? Plugging in a 0 for x. That means these guys here would be gone, and we would have a negative 1. So at 0, I have a negative 1. So that already tells me, I already have 1 point there, and that tells me that this part of the graph must do that. So the other points are just up to us to give a shot here. We need something in between here. Why don't we try negative 4? I just chose it because it's in the middle. Now when we plug in the negative 4, I find it much simpler to plug into the factored version than the unfactored version. I don't know if that's what we'd call it. So here we would have a negative 12 over negative 4 plus 6 is 2. Negative 4 plus 2 is negative 2. So I have negative 12 over negative 4, which is positive 3. So I have an ordered pair at negative 4, 3. So that means here in the middle we must be like this. It may not be perfectly parabolic, but it's going to look like that somehow. And then checking a point to the left of negative 6. Let's try, how about negative 8 for fun? It doesn't matter. We could do negative 1,000,000. It would just be more work than we need, right? Negative 12 over. See, negative 8 plus 6 is negative 2. Negative 8 plus 2 is negative 6. So I get negative 12 over negative 12, which is a positive 1. Which it can't be a positive 1, so what did I do wrong? Negative 12, negative 8 plus 6 is negative 2, negative 8 plus 2 is negative 6. Oh, sorry, that's positive. You probably already found my error, right? So I get negative 8, negative 1. So this side will go that way. Let's look at the next one. Again, I'm going to go ahead and factor my original. I'm going to go ahead and take that negative 10 out of the top. X minus 2 over. And then when I'm factoring here, I have x minus plus. Two numbers that multiply to give me 20 and subtract to give me 1 are 5 and 4. Starting with our vertical asymptote, we have vertical asymptotes at x equals positive 5 and negative 4, right? So here's my negative 4 and my positive 5. Okay, so the next thing is looking at that behavior. So as x approaches negative 4 from the left, look at our factors here. We have negative, and then if I'm less than negative 4, this factor will also be negative. If I'm less than negative 4, say I'm at negative 8, this would be negative, and this would be negative. And so that's positive over positive. That tells me that f of x then approaches positive infinity. So this guy here is going to be going up. Next, we want to look at negative 4 from the right. So we're greater than negative 4. In the numerator, we're still going to have negative times negative, right? Because if I'm at negative 3, right, that factor is going to be negative. In the denominator, again, thinking about a negative 3, I would have negative positive. So that means that our function is approaching, we would have positive over negative, which is negative infinity. Now we want to look at the 5 as x approaches 5 from the left. So we are less than 5 but positive, right? We still have a negative for the 10. If we are more than 5, this top guy here is positive. Well, not more than 5, I'm sorry, less than 5 but positive, right? Here we're less than 5 but positive, so maybe a 4. So that would be negative. And this guy would be positive. So we have that the function is approaching positive infinity. So we're up here. And then if we go from 5 to the right, we still have that negative 10. Now if we're more than 5, that next factor is positive. then in the denominator we are positive, positive. So our function is approaching negative infinity. Looking for a horizontal asymptote, this is bigger on bottom, y equals 0. Notice that if my behavior here is down and here is up, and these are my asymptotes, we are going to have to cross this axis, right? All right, so next we are going to look at x-intercepts. They are zeros of the numerator, and since this is factored now, I can easily tell that I have an x-intercept at 2. So on my graph, there's my 2 where it crosses. Looking at my y-intercept, that's f of 0. And for that, it's easiest to go into my non-factored guy here. And we get a positive 20 over a negative 20, which is a negative 1. So 0, negative 1. So that tells us that over here, we're doing this somehow, right? So then we're just looking for a point on either side here. So let's see. Over here, we could try a negative 5. Again, I think it's easiest to check to do this in the factored form. So we would have a negative 10 times negative 5 minus 2 is negative 7 over. Negative 5 minus 5 is negative 10 times negative 1. My negative 10s go and I get a positive 7. So negative 5, 7, which is not surprising, right? Because we expected that to go up. We know we don't cross the x-axis again because we don't have any other x-intercepts, right? And then checking the right-hand side, I'll check f of 6. Hopefully you're thinking it should be down here, and you would be correct. Just like polynomial multiplicities, the multiplicities in the denominator also matter. So since these are both single multiplicity, they're going to alternate, right? They're not going to be next to each other. Looking at f of 6, I have negative 10 times 4 over 1 times 10. So I get a negative 4, 6, negative 4. So this guy goes here. All right, one more. Negative x squared minus 9x. I'm going to factor both of these guys again. I'm going to take the negative x out of the numerator, and I'll have x plus 9 over 2 sets of parentheses xx plus plus. Two things that multiply to give me 18 and add to give me 9 are 6 and 3. So first thing, I know I have 2 vertical asymptotes at negative 6 and negative 3. I could go ahead and do the horizontal asymptote also if I like. This is x squared over x squared. This is exponents are the same. Divide the coefficients. So my horizontal asymptote will be y equals negative 1. All right, so now we're going to look at the behavior. So let's talk about what happens. I'm going to kind of shortcut it here as we approach negative 6 from the left. So we would have, let's see, we would have negative, pretend it's a negative 7, right? So negative 7 plus 9 would be positive over negative, negative. So that gives me negative. If I'm coming in from the right, so let's just pretend we're at a negative 5. Oh, wait, I didn't do that right, because this is negative x, but if it's negative, this is positive. So we're up here, my bad. So now if we're at, let's pretend we're at negative 5, This guy would be positive, positive, over, positive, negative. So he's negative over here. Don't get confused with my mistake there. Now we're going to look here as we approach -3 from the left. We can pretend we're at -4, and we're going to get positive, positive, over. Again, we're pretending we're at -4, positive, negative. So we're down again. And then to the right, or from the right, excuse me, we can pretend we're at -2.5 or -2 or -2.9. It doesn't matter. We would have positive, positive, over, positive, positive, which is positive. So where am I going to expect there to be graph? Here, here, and here. So let's see what we got. Okay, looking at x-intercepts, zeros of the numerator. We have 2 x-intercepts at 0 and -9. That's kind of weird, huh? Zero. Oh no, it's fine. I was thinking that the asymptote was on the axis, but it's not. So we got -9 over here. So we know that's going to happen that way, right? And we know this is going to do that. And we could extend this. You know this isn't going to cross, right? Looking at our y-intercept, f of 0, notice that here the only thing that wouldn't go away would be the 18. So we would have 0, over 18, which is 0. And we've already got that graphed. Right? So next we're just choosing some points. How about -4? So I'm just going to plug it in. I would have a +4 times a 5 over 2 times -1. So 10 over 2, -5. So I said -4, -5. So this somehow does that.